Here are the problems that will be solved in this video. We also summarize on these concepts that are important to solve the problem. You can pause this video at any time to read the question or when you solve yourself. Let us go to the first problem. Let us solve the first problem. But before I discuss about the problem, it is important to know these concepts. Gravitation field, gravitational field strength, gravitational strength. They are all the same, equal to g times m source divided by r squared. If we multiply by the mass of the other body, we get gravitational force, which we are very familiar. The gravitation field is the concept and cannot be measured, whereas the gravitational force that is written on the right can be measured because force, can be measured. What if I tell you that you know the gravitation field strength at the surface of Earth all along? It is nothing but g, which is 9.8 meter per second squared. Corresponding to it, when you multiply the other mass, we get the gravitation force at the surface Earth, which you are very familiar. It is m times g. Now, the last one, gravitational potential, is given by negative g times mass of the source divided by r, not r squared. When you multiply by the other mass, it gives you the potential energy. It is minus of gm times other mass divided by r. With this knowledge, it is easier to solve this problem. Let us go to the next page. In this problem, they ask at what point the gravitational field is zero. Then they ask at that point, what is the gravitational potential? Let us draw a schematic diagram of two objects. Where do you think the field will be zero? Field is a vector quantity. On the left, it will never be zero as both mass will attract to right. It will not be again to the right. Yes, it looks in between the two masses, the field can be zero. Let us say, at distance x from the smaller mass, the field is zero. Then, at a distance r minus x from 9m mass. The field at that point will be same and in opposite direction. We do the math and find that we need to solve the quadratic equation. Let us solve this in next page. Here, in this page, we have written back the quadratic equation. I hope you remember the quadratic equation solution because we will use this to solve, and we get two solutions. One solution shows x is negative, and we ignore it because it is impossible. We take the other solution, and we get x equals r over 4. Now, we are asked in the question to calculate the gravitational potential at x equals r divided by 4. The gravitational potential due to both masses at x equals 4 is given by negative g times m over distance, which is x from small mass m and r minus x from 9m. Do some math, and we finally get negative 16 gm divided by r. This corresponds to the answer choice of D. And let us go to the next question. To solve this problem, we are asked to find the quantity, 3 pi divided by g times density. The answer choices are given in terms of time period. We start by writing the formula of orbital velocity. The circular velocity is related to angular velocity as v equals r times omega, and omega is related to time period by definition as omega equals 2 times pi divided by t. We now apply to the orbital velocity and eventually get this relation. We are not sure we will succeed, but you have to trust yourself that we may get the answer because the t is involved. We now start with 3 pi over gd as given in the question. We substitute the density as mass of Earth divided by volume of uniform spherical Earth. We need to do the algebra. We ignore the number constants for quick calculation and get r cubed over g times mass of Earth. Wait a minute. G times mass is something we got before that we wrote in blue. We substitute and ignore the constants, and we get t square. If we have not ignored constants, we will still get t square, but in competitive exams you have to learn to be fast. The answer is C. Let us go to next question. In this problem, They are asking for calculating mean density of Earth. They have given radius of Earth, r, and acceleration due to Earth, g. So we write the gravitational field strength as this. Now we start with density of Earth as mass of Earth divided by volume of Earth. We assume Earth is uniform and shaped as sphere. Now, in the answer's choice, does not have mass of Earth. So we take the equation of the left and solve for m so that we can substitute on the right. And we get this, and the choice of answer is C. That ends the video.